key for the Unit 3 study guide. Questions number 1, 2, and 3. We need to go ahead and graph these absolute value functions and then provide the key descriptions from them. So starting off, for each of the absolute value functions, we want to go ahead and identify h and k. H here is 2, k is -4, h here is -4, k is -1, h here is -1, k is -4. So plotting all these points to -4, -4, -1, and -1, -4. We now go ahead and go to our a value. In number 1, it is 1 over 1. Here we have -1/2, -1/2, and then in 3 we have 2 over 1. So go ahead and use this a value to graph. In number 1, up 1 over 1, up 1, back 1. In number 2, down 1 over 2, down 1, back 2. And in number 3, up 2 over 1, up 2 over 1, up 2, back 1, up 2, back 1. Okay, so now that we have all of the graphs done, we can go ahead and work to identify the key features. We'll start with number 1. We need to identify y-intercept, zeros, domain, range, increasing, decreasing, and end behavior on all of these. So starting off, visually looking, we should be able to see that our y-intercept is at -2, the point 0, -2. For our zeros, we look where it crosses the x-axis. We see 2 key points at -2, 0, and 6, 0. For the domain of this function, domain is how far left, how far right does the graph go. We look for the very edge of the graph. For the left, we see that there's an arrow, meaning it goes to -infinity. We follow the function, there are no breaks in, and it ends up over here where there's another arrow, which means positive infinity. Our domain is -infinity to positive infinity. For the range, we start at the very bottom of the graph here. We see there is the low point of the graph, and that has a y value of -4. And we go to the very top of the graph. There's no breaks in between, and we see another arrow. That, in terms of y's, means positive infinity, giving us bracket -4, comma, infinity. Remember, domain and range is the only one where we use hard brackets if we have a point. Next, increasing and decreasing. Where is this graph going up? Well, we clearly see the graph is going up in this region. It starts here, and that is an x value of 2, and it continues to increase all the way to here where there's an arrow, which in terms of x's means positive infinity, giving us the region 2 to infinity. Where is it decreasing? Well, we see it's decreasing everywhere in this region. It starts here, which is an arrow in terms of x's means -infinity, and it goes down and decreases to here, which in terms of an x value is +2, giving us the region -infinity to 2. End behavior of a function. End behavior is what is the graph doing as I move to -infinity? What are the y's doing? As I move to positive infinity in the x's, what are the y's doing? Well, as I move to -infinity in the x's, the graph is here. I see an arrow, it's going up. That's in a y value is positive infinity. As I go to x equals positive infinity, the y graph is also going up, so that means in terms of y's, it's going to positive infinity as well, giving us infinity and infinity. Okay, so the other graphs we approach the key features in a similar way. Take a moment to see if you can do those. I'll reveal the key here. There are our values. Something to make note of is the domain in each of these functions ended up being -infinity to positive infinity. That made sense. It is in fact the range values that changed each time, whether we started from -infinity to a value or we went from a value to positive infinity. Something to note of that as we look at all the absolute value functions.